everyone, welcome to Module 10. We're going to take a look starting on page 594, 595, at performing a what-if analysis. So basically what we're going to do is in session 10.1, we're going to look at the principles of cost, volume, profit relationships. In number 2, we're also going to take a look at one variable data tables and two variable data tables. In 10.2, we're going to create and apply different Excel scenarios in the Scenario Manager. We're going to generate a scenario summary report, and we're going to create a scenario pivot table report. And in 10.3, we're going to explore principles of a product mix. We're going to run solver to calculate optimal solutions. We're going to create and apply constraints to a solver model, and we're going to save and load the solver model. And as you can see from here, because I'm incredibly lazy, just like last week, I'll be going through the textbook video it's the textbook example instead of making my own. So bear with me and let's figure it out together. So we're starting off on page 595, and this is the data file called Cultivar, I think. If I'm pronouncing that wrong, I apologize. So here we go. Irina Rostov manages the production and sales in the lawnmower division at Cultivar Tool, a manufacturer of lawn and gardening equipment based in Chesterfield, Missouri. Irina wants to use Excel to analyze the profitability of a company's line of power lawnmowers to determine the number of mowers the company must produce and sell in the second quarter in order to be profitable. She's interested in whether the company can increase its net income by reducing the selling price of the mowers in order to increase the sales volume. Okay, so what that means is she wants to know, should we make the lawnmowers cheaper and therefore people are going to buy more of them? Your analysis for Irina will focus on your 4 most popular models the company sells. As part of your analysis, you will also study whether the company can increase its profits by promoting one model over another. In this process, you'll try to find the best product mix, one that maximizes profits, subject to limitations of customer demand, available parts, and manufacturing capability. Okay, so next we're going to take a look at the overview on 596 and 597, and you can see that we have the sheet open here from the data file, and we're on the income tab. Okay, so the first thing we're going to talk about is cost, volume, profit analysis that you can see on page 598. And we're trying to figure out the relationship between expenses, sales volume, and profitability. Do we make the item cheaper and manufacture more, or do we make the item more expensive and manufacture less? Which one would result in being able to make more money and sell more lawnmowers? Okay, read over 598, 599, and 600 to get an idea of CVP. But basically the idea is that we have 3 factors in this analysis: variable expenses, which change depending on how many we make and so on. Fixed expenses are things like the rent for our factory that we have to pay no matter how many units we produce. It's always going to be the same. And we have mixed expenses, which is part variable and part fixed. And you can see examples of those in figure 10.1, 10.2, and 10.3. Finally, the chart that we have on 10.4 shows the difference between fixed expenses, variable expenses, and most importantly, our break-even point, right? And this is called break-even analysis. So open up the worksheet and let's get going. Okay, so first in 10.5 on page 601, we're going to look at 12,000 units produced. The average price per unit is $335, and that means that we're going to make $4,020,000 by selling 12,000 mowers at $335. Okay, so that is our revenue. Next is our variable expenses. Okay, so we have 12,000 units produced. The average cost to produce a unit is $155. So that means that we have to spend $1.86 million on manufacturing the lawnmowers, and we basically take that out of here. Average manufacturing cost per unit is $70. Total manufacturing cost is $840,000. So this will be like labor, machines, etc. and total variable expenses would be $2.7 million, right? However many we make, that necessarily changes. We also have fixed expenses like salaries and benefits. We're going to have to hire people to work in the factory. Whether they produce a little more or a little less, it'll be the same. Shipping and distribution, stocking and storage, and miscellaneous is going to equal around $1 million. And finally, we have our total revenue, which is $4,020,000. Our total expenses is $3.7 million, and we end up with a net income of $300,000. Okay, so that's deducting one from the other. So this is all the money we're bringing in. This is all the money it costs us to manufacture, ship, and sell those items, and this is what we're left over with. So let's start working on the example at the bottom of page 601. What if analysis lets you explore the impact of changing values in a worksheet? You could use such an analysis to explore the impact of changing financial conditions on a company's profitability. Irina wants to know what impact there would be if we produce and sell 15,000, which is going to be more than 12, or if we sell 9, which is going to be less than 12. So we have to decide, should we increase production or decrease production? How is that going to impact the company? Because maybe right now at 12,000, we're only making $300,000. Maybe we could find a better scenario of producing a little more, a little less to help us do that. So let's go through the what if analysis. We're going to go to B6 and we're going to change this to 15,000. Okay, so now we have $630,000 in B28. Or not? Interesting. All right, let's figure out what happened. 15,000. Hang on. There we go. So we changed it to 15,000, and then our net income is now $630,000. In cell B6, let's try 9,000. Okay, and at 9,000, we actually lose $30,000. So let's go back to 12,000, which is our initial projection, and we're going to make $300,000. Next, Irina wants to know how low sales can go and still maintain a profit. In other words, what is the sales volume of the break-even point? One way to find the break-even point is to use GoalSeek. You know, we used GoalSeek in the past when we were looking at the soybean acreage crop. If you remember, I think it was module 3 or 4, somewhere around there. And we were trying to find out how we could best fit one number into another. Recall that GoalSeek is a what-if analysis tool that can be used to find the input value needed for an Excel formula to match a specified value. In this case, you'll find how many mowers have to be sold for the net income to be 0. So let's follow the steps from the box on page 602. On the ribbon, click on Data. There we go. And we're going to go into the what if analysis. And we're going to go to GoalSeek. Okay? So now we have 3 options here. In the income worksheet, set B28 to replace the selected cell reference in the cell box to B28. Perfect. The absolute reference specifies the net income of the cell that you want to set. Next, we're going to press Tab or click it to move to the to value box, and then we're going to put in 0. Okay, so we want to see what number has to change to get to 0, and we're going to do that by changing B6, right? So basically, we want to set this cell down here to 0 by changing B6. Okay, we're going to press OK. It's going to run through all the different combinations, and it's going to tell us to get to 0 in our total net income, we have to sell exactly 9,273 lawnmowers, I think we're selling. So the idea is that this is our break-even point. If we sell any less than this, we're going to lose money. If we sell any more than this, we'll make money. So let's see, if we sell 9,500, then we actually make 25,000. So our goal here was finding out what is the best, like what is the minimum point, and then we could base our numbers off of that. In this scenario right here, we sell this many, we actually break even and get to 0, which is exactly the same as the chart that we saw on page 600, right? we're calculating that break-even point between loss and profit. Okay, so let's reset to 12,000 and we'll keep on going. So of course, Irina is not happy. She's never happy because it says, Irina wants to continue to analyze the company's net income under different sales assumptions. What would happen if the company's sales increased to 16,000 or it went down to 8,000? How many motors has the company has to sell to reach a net income of exactly $50,000? So we can continue to use GoalSeek over and over and over again and answer all these questions, but we could more efficiently do that with some data tables. And you'll notice in this example that column C and column H have already been formatted to kind of look like the example that's in the overview of this module. So we're going to create tables like that so at a glance we could see what the difference is. And we had something similar last week when we looked at different scenarios in the Mind project, and we looked at different scenarios in our other projects, so we could see based on the data table what the story is. So we're going to create a data table, which is the result of a bunch of different what-if analysis. The table consists of input cells and result cells. Okay, so we're going to have both kinds. The input cells are the cells that the values would change in a what-if analysis. The result cells are the values that we get by changing the input cells. In Excel, you could use a one variable data table and a two variable data table. There you go. So what is a one variable data table? And we're on page 603. In a one variable data table, you specify one input cell and any number of result cells. The range of possible values for the input cell is entered in the first row or column of the data table, and the corresponding results values appear in the subsequent rows of the columns. One variable data tables are particularly useful in business to explore how changing a single input can impact several financial measures. Okay, so let's take a look at 10.7 on page 603. And it shows how a one variable data table is used to determine the impact of different interest rates on a $315,000 loan. And we did this when we did loans last week with financial calculations, and we showed how we built that table showing how, depending on how much we're borrowing and how long and how many payments and so on, we could come up with different scenarios looking at the best possible outcome. All right. Okay, so let's set up our one variable data table, and that's going to be on page 604 in the yellow box. So let's go to D4. Here we go. And we'll put in break-even analysis. So now they want us to merge and center D4 to G4. So we're going to click on Home, and then we're going to go to where it says Merge and Center. Okay? And then they want to format the text with heading 3 cell style. So let's go to Format. Nope. Click here. Here we go. Heading 3. Alrighty. In D5 to G5, so now we're in D5 to G5, we're going to put in units sold. Okay, then I put in units sold, revenue, expenses, and net income, and I gave it the accent 2 color. Okay, next in D6, we're going to put in B6. In E6, we're going to put in B26. And in F6, we're going to put in B27. And then finally, in G6, we're going to put in equals B28. Okay, so that copied, it basically took the information that we have here on the side, and it copied it into the table. Okay, so I went through the rest of the steps here, and we have 2,000 to 18,000 units set up as a reference. I put a line underneath our units sold, revenue, expenses, and net income, so we're dealing with right now at 12,000. And then I formatted everything to just be a number with no decimal places. Okay, so the idea is that we're going to fill in this cell using Solver. I'm going to come up with a whole bunch of different scenarios, which we did manually here, but we're going to have them all displayed simultaneously so we can begin to explore what our options are. Okay, so now we're on page 605, and we got up to 10.8. You'll now have a complete table with, we'll now have to complete the table with result values. To do this, you must identify row input cell and the column input cell. The row input cell is used when the input values have been placed in the first row of the data table, and the column input cell is used when the input values are placed in the data table's first column. So that's going to be up here and over here. In the income worksheet, the input values are in the first column, so you use the first column input cells option. Exciting. If you had oriented the table so the input values are in the first row, then you'd use the row option. Okay. So how do we do this? Select range D6 to G15. So D6 to G15, got the whole thing there. On the data tab, go to forecast, data, what if, nope, that's not it. Yeah, click on what if, and then press where it says data table. All right, so it's asking us for two things. The first one is we could either use row or column. So in our case, we're going to press tab or go down to the second one, and we're going to click on B6. That was D6, right? Or B6? No, they want this one. There we go. All right, we hit enter. And then we press OK. There seems to be a glitch in the matrix. Let's figure that out again. Okay, well, if you were following along, you probably saw the mistake I made. If not, let's check it out again. So when I selected, I went over here and then picked the 12,000 to fill these guys out. But Solver doesn't know, what if analysis doesn't know what these numbers are and how they're related. So we actually have to give it our first example this way, okay? Then we're going to go to what if analysis data table, and the column input cell is going to be 12,000. So we're saying that 12,000 here is the same as here and influences all of these. So we press OK, and then it will fill out these on that same basis, okay? And next, let's take a look at Format Painter. I find this funny because I had no idea this tool existed. Okay, so we're going to click on Format Painter, and we're just going to drag down like this. And that didn't work at all. Format Painter. Let's try it like this. Go here, Format Painter. Nope. Give me a second. Let me work on this. As usual, I wasn't following the directions. Okay, so step number 5. Click on B26. I got that here. Then press Format Painter, and then go like this. All right, so that makes more sense. So now our picture looks exactly like figure 110 on page 606. And then finally, let's pick cell G15. That's going to be right here. Okay, so let's take a look at what's happening in the table. First, we said if we produce 12,000 units, we're going to have a revenue of just over 4 million, expenses of 3.7 million, and that's going to give us a net income of 300,000. We found our break-even point, and now we're exploring scenarios between producing 2,000 and 18,000 lawnmowers. Let's take a look at what the numbers are. So at 2,000, our revenue would be 670,000. Our expenses would be 1.4 million. That means we would lose 800,000. And keep in mind that a lot of this is our fixed expenses, right? So we have those three factors that we talked about before. Let's go down here. If we produce 10,000, then it's going to cost. Then we're going to bring in 3.3 million, but it's going to cost 3.2 million to manufacture them, meaning we're only left with $80,000. At the far end of the spectrum, if we create 18,000 of them, we're going to bring in $6 million. Our expenses will be $5 million, and we'll make 960,000 profit. And each line, each row, is a separate solver, right? That was done over and over again using the same pattern from here to here, like this. We filled in the rest of these based on our row headers. Okay, so now we're on page 606, and let's put this into a chart. So the data table provides the results of the what-if analysis, but the results are often clear if we put the CVP chart alongside the table. Okay, so basically we want to see the break-even point and the number of units sold. So we're going to select the range D5. Okay, so here we have D5 to F15. There we go. Let's go to Insert. And we're going to go to Scatter or Bubble Chart button. All right, so here we go. Scatter. And we're going to pick scatter with straight lines. There we go. Is that one? There we go. Scatter with straight lines. Okay, so each point in the data table is plotted on this chart and connected with a line. The break-even occurs where the lines meet. So that's going to be right here is where the break-even point happens. Okay, so on one axis we have the amount of revenue and expenses. And then on this side we have the number of units sold. Okay, so I put my chart in, I colored the back of the chart like it says in the example 10, 11 to a gray color, and I have my two lines on the inside. And just to be more accurate, I changed the line to red for expenses, and you can do that by clicking on the line, and I just went to fill, change the color to red. Okay, so it looks more like the textbook. I could click here, and if I want, change the color of the green as well. Okay, so basically I have it looking like it does in the book, but you can play around with this, of course, and make it look however you want to present the data, right? If you want a little less gray, there you go. Okay, and I resized it to match the size of our columns, because when I first created it, it went over into I. I'm just going to align it with everything else so it matches up nicely. All right, there we go. Okay, so now we'll move on to our next point. So we're on page 607. But just to remind you that all of this, all these numbers, are based off of our initial calculation on this side, right? That feeds into our first row, and then everything else are projections based on that. So if we change one of these numbers, everything else will change in the chart and the table. Okay, so let's take a look. Basically, if we're interested in changing the price in B7 to 300 instead of 335, what happens if we make our product a little cheaper? Is that going to help us? How's it going to impact our break-even point? So we're looking at a slightly different scenario. Okay, so we put in 300 into B7, and it's going to change. So the break-even point now is far higher than it was before. So now we're over here instead of being over here in the center, right? And now we could see that when we produce 18,000 at $300, we actually only make $330,000, right? Whereas before, when we were at 335, not only is the break-even point far lower at around 10,000 units made, but now when we produce the same 18,000, we make almost $1 million profit. So that makes a significant difference. Okay, so we're at the box at the bottom of page 607. We're going to set this to 300. And we're going to look at, on page 608, what we have right here. And we're going to take a look at what the different numbers mean. So in this scenario, this would probably be not as good as the difference. So we'll go back to 335. It says that the analysis indicates that the tool company will have to sell 14,000 mowers to break even at the lower sales price. We could perform a what-if analysis with different sale prices to look at the impact. So we could keep on doing this, right? Like let's try 400. Okay, if we at 400, if we make 18,000, we'll make $2 million. But our break-even point is actually going to be really low at around 6,000, approximately between 4 and 6,000, and that will be all the way down here, right? Our break-even point actually might be just over 5,000. So, you know, that is a consideration for maybe we should do 400, or well, depending on what's in the market, should we go with 200? And 200, we basically lose money no matter what, right? So that's not very good. With 250, we lose a lot of money, so that's not great. 300, 300, we actually have the potential to make money. It's a little higher, right? But it only starts at around 14,000 units. So that's the idea. We could play around with this, or we could build another table to compare them side by side and do this whole process really quickly. Okay, so essentially copy what we have here. And next we're going to look at a two variable data table to do just that. Now, if you're interested in how the formula for CVP works and how to calculate the numbers to turn into a formula, you can see that in the blue insight box on page 608. Okay, and we're going to move on with a two variable data table at the bottom of 608. Okay, so if you remember with our one variable data table, we only actually gave one variable that changed here that we put in, and then we based the rest of the numbers off of if these numbers were substituted for here. And now, in our next example, we're going to look at what happens if we have two input cells and one result cell. You can see an example of that on 1013, which is on at the top of page 609. Okay, so now we have two input cells, so we changed two different numbers, and that gives us one single result. Okay, so now we'll go through the box, the yellow box on the bottom of page 609, and we'll set up the two variable data table. Okay, so I'll just set up all the headings. Okay, so I set it up according to the instructions with the number of units, the same as the number of units here, but across the top, we're going to look at the average price per unit, like we did before experimenting in here, but now we're going to create a table going out this way. So we're going to look between these two variables, whereas here we're only using one variable. Okay, I'm at the last step right now, so in I6, I'm going to put in equals B28. That's going to bring in our starting point. Okay, so that basically gives us what we have in 10.4. The two variable data table is completed using the data table command using the one variable data table above, except that you specified both rows and columns. So let's see if we can figure that out. Select from I6 to N15. So basically the same thing we did before. Get the whole box in there. We're going to go to Data. We're going to go to What If Analysis and click on Data Table. This time, we're going to pick both a row and a column. So in the row, we're going to put in B7. And then in the column, we're going to put in B6. Okay, so B7 is going to be our 335, and B6 is going to be our number of units. So that's going to be here and here. Alrighty, so we're going to press OK. There we go. So now we have the numbers from the number of units. Okay, so we're going to use Format Painter, and let's try to get it right this time. We're going to go to G15. So I'm going to go right here. Okay, then I'm going to go Home, Format Painter. And then I'm going to apply the Format Painter to here. There we go. Okay, so this is going to show us the table that we see on page 611 in figure 1015. Okay, and basically what does this mean? The break-even points for the different combination of price and units are easy to track because negative values are red, positive values are black. Okay, so let's see, at $400, right, we break even at around 6,000, like we said before. At 18,000 units, we're at $2 million. Whereas if we only produce 2,000 units at $300, we would lose $870,000. So this gives us a good idea of where we want to be in that central line, and we could pick different combinations. So for example, if we look over here, 14,000 units at 350, we would make $730,000, right? Or maybe because we want to compete with the price in the market, we actually want to go for 325, and we're like, well, if we could increase production to 16,000, then that would give us $580,000 profit. So by playing around with these, we could try to balance the numbers and find the best fit between the price and the number of units produced. Okay, so that's all great, except we want to take out this 300,000 up here at the top. So right now, this is pulling in B28, which is this number on the side. But because it has the 300,000 in there, people might not understand what exactly that is. So we're going to hide it. Okay, so we're going to click on cell I6, and we're in the box at the bottom of page 611. We'll go to Format Cells, or press Control 1. Let's press Control 1. There we go. And we're going to go to Custom. There we are. Okay, and in the type box, select any text and type units sold. Let's go up here, and we'll type in units sold, including quotation marks. There we go. Units sold. Sample, units sold. And then we press OK. Okay, so now units sold, it doesn't name the cell, but what it does do, it creates a new type of text which will only display as units sold. Okay, so that basically hides the underlying number that's underneath it. Okay, as it notes, there's other ways we could do this too. Like for example, we could change the text color to white instead of black and the background to white, and the text will disappear. But regardless, this actually helps us because it will explain this is going to be the number of units sold, this is going to be the price, and then we see the difference between them. Okay, so we do that using a custom type of text, right? So we could do that with a bunch of other labels as well if we want to hide numbers behind them. Okay, so just like we did here, we created this chart to show us the one variable data table. Here we're going to create a chart showing us the two variable data table. Okay, so we're going to get started at the bottom of page 612. So we're going to grab the range I7 to N15. Okay, so I7 to N15. So we're going to go to Insert, and we'll go back to our scatter plot, and we're going to go to Scatter with Straight Lines. That's this one right here. Okay, same chart that we chose before. Okay, so remove and resize the chart so it goes to N28. All right, how about we go like that? Okay, looks good. We have them sort of matching. It's not bad. Have to play around with it a little to get it exact, but oh, it's all right. Okay, so remove the chart title and position the chart to the right. So to remove the label, we just go up here and press delete. And the legend is down here on the side. We need to move it to the right. So how do we do that? We go to up here. Let's click on legend, and we'll put it on the right. There we go. Okay. Okay, so, oh, I almost had it. Let's go in here. There we go. And we'll fill this with white. There we go. So now we have exactly same kind of chart. So the back is gray, front is colored, and we see here that this line, our zero line, is where the net income line crosses the horizontal axis. So this is each of our series, right? And this is how many units they have to produce to break even, which is the same kind of chart that we have here, right? But this doesn't make much sense because we still don't know exactly what these things mean. So we're going to have to edit the chart series because right now they're just called series 1 to series 5. Okay, so what we're going to do that is we're going to click on select data. So click on the chart. There we go. And we're going to go to Design tab. And then we'll go to where it says Select Data. Then we're going to go to where it says Series 1 and press Edit. And then within the insertion point in the series name dialog box, we're going to pick J6. Okay. And that's going to give us 300. And we press OK. All right, so now instead of it just being series 1, series 2, series 3, series 4, it's going to be called 300, 400, etc. And let's repeat that step. And here we go. So here we have the names, instead of being series 1 to 5, are now the prices that we have across here at the top. Okay, and then we change the colors by going to Design, Change Colors. And we picked one of the monochromatic ones down from the bottom with different shades of green. And now you'll notice that the heavier the line, the darker the color, the more expensive it is. So that gives us an additional piece of information inside our chart. So if you look at the top line right here, we have the 400, that's this column right here. It's the darkest line, whereas the most grayed out line, the faintest line, the 300, is the one over here. Okay, so that gives us another visual difference. Now, what does the chart actually say? The chart shows how different unit prices will affect the relationship between sales and volume. The horizontal axis, which is this away, is the number of units for the break-even point. For example, the 325 line, which is this one, crosses the horizontal axis near around 10,000 with the average cost of 325. The company will have to make 10,000 mowers to break even. Okay, so here we would, if we're going to sell $400 if we're going to sell $400 mowers, we'll have to sell far less of them and make a lot more profit. The real issue is, even though this sounds great on paper, can we actually sell a $400 mower? Will our customers buy that instead of buying the $300 mower of our competition? Do we have to compete at a lower price point? Can we have a more premium product that they'll pay more for? And that's really what we have to figure out, like looking at the difference between these two numbers. So what do we do here? We've used the what if tool with GoalSeek to analyze how much the tool company has to charge for its mowers and what impact these different factors have. So you can understand how if we did these exact same calculations and tables for any other product, we would have a good idea between how many units have to be sold, revenue, expenses, and net income, and also how many units compared to price. So we could run these different scenarios to come up with different potential options. Okay, so you've made it to the end of 10.1, and if you want to keep on going in the module, please turn this off, go to 10.2, which is the next video, and we are going to be talking about what-if scenarios. However, I'm going to take the next few minutes just to talk about the blue box on page 615, which is an additional note. We have talked about it before in class, but if you weren't there, or if you're in the online class, or if you're just interested for how certain advanced functions work, we'll go into that a little bit. Okay, so just to give you a little more background. Okay, so if you're still here, let's take a look at the blue box on page 615. If you examine the cells in two variable data table you created, you can see something different. Ooh! So let's click on any cell in here, and you'll notice that we have our equals table B7 to B6, so that's our normal function that we have, but you'll notice that they're in special curly braces. Now, those curly braces indicate that we used Control-Shift-Enter to make those happen. If you change those, or you take those out, or you put in a different formula, it won't work anymore, because they work on a different layer than we've seen otherwise. These are called an array formula, which performs multiple calculations in a single step, either returning a single value to one cell or multiple values to several cells. Array formulas are in curly braces. Now this is important because normally we can only do one thing in each cell. Here we could do a whole bunch of things simultaneously, but they have to be in this special format. We've mentioned in class that if you're working on a sheet that has array formulas and you give it to somebody else, they may not know that and just press enter, and by pressing enter it actually breaks the table and doesn't work anymore, right? The array cell will only function if when you're done with it you press Control-Shift-Enter to go to the next one. So that's when you would go and put in a comment, like with review we talked about new comments, and you would say, note this has a array cell, or you put in a documentation sheet saying the same thing, right? So that's a really good idea. One example of an array table is that it returns a single value is equal sum B10 to C10 times C10 times C1 to C10. Okay, so it's doing a whole bunch of calculations, but it's only doing it in one step. The formula multiplies all of B1 to B10 by matching the cell in the same row as C1 to C10. The sum of those 10 products is then calculated and returned. So it's going, instead of what we normally do, is having it multiplied up and down and then added together, here it's going sideways and then multiplying it all together. So essentially, we're doing 11 calculations with one short formula. Excel treats these formulas as an array formula, adding the curly braces for you. So that's how you know if it's an array, because you'll see those curly braces on it. The table function is an array function that returns multiple values to cells. Other functions include trend, miniverse, MMULT, and transpose. And to make any of those work, you press Control-Shift-Enter after you enter the formula, and then it applies the array. Okay, so if you're interested in arrays, you could read about them on the Microsoft site, as well as you could take the advanced course where there's tons more stuff about arrays. But the bottom line is that they do very complex calculations in a single step, and they could save hundreds and hundreds of steps of formulas by going through a lot of data really quickly. but you have to use them very carefully because they could be easily ruined. Okay, so just as a side note. All right, so now we're done for real 10.1, and we'll move on to 10.2.